section 9.2. That's called graphs of quadratic functions. The parent graph of a quadratic function looks like this. Y is equal to x squared. If we were to graph all points that satisfy this, it looks like this. This graph is called a parabola. Parabola has different parts. We have a point on the very bottom or a point at the very top. That's called the vertex. And we use the coordinates h, comma, k to represent the vertex. We also have something called the axis of symmetry, which cuts the graph right down the middle. You have the same exact graph on the right side as you do on the left. If you were to reflect it over, it would be exactly the same thing. The domain for this, remember we talked about two types of restrictions. Look at the original function, y equals x squared. Is there a radical? No. Is there a denominator? No. The domain is unrestricted, negative infinity to positive infinity. The range, we look at the graph. Smallest y goes is 0, and then it just goes up for forever. Remember, domain, of course, are x values. Range would be the y values. The axis of symmetry the equation of it would just be x is equal to h. And we'll be practicing all of this stuff in the next few examples. We could abbreviate axis of symmetry to AOS. We are going to be talking about how to move this graph, how to stretch it, and how to reflect it. Those are called transformations. And there are 3. One type of transformation is called a translation. Translation, by adding or subtracting, moves a graph left, right, up, or down. You always get a translation whenever you're adding or subtracting a number. That what's called a dilation. Anytime you multiply by a number other than 1. And this is just going to make the graph narrower or wider. And again, that's if you multiply by a number other than, let's put positive or negative 1. As long as you're multiplying by a number that's not positive or negative 1, you get a graph that looks narrower or wider. And then the last thing that could happen is something called a reflection. Get a reflection by multiplying by a negative. And this just flips the graph over the x-axis. show you what this would look like here. We have different forms. Today, we're going to be focusing on what's called vertex form, which just means we have a graph where it's y is equal to a times x minus h squared plus k. That's one form. The other form I'm just going to write on the side here. It's called standard form. Standard form, we write y is equal to ax squared plus bx plus c. Spoke a little bit about this when we were talking about quadratic formulas, but when we're graphing, typically we want to write everything in vertex form. And we go from standard form to vertex form by completing the square. We talked about that in our last class. Let's focus just on vertex form. And I'll tell you what these numbers do. The k value is going to translate the graph up or down. If k is positive, the graph goes up. If k is negative, the graph goes down. The h value is going to move the graph left or right. If it says x plus a number, you're going to go to the left. If it says x minus a number, you're going to go to the right. And then this number in front, a, if a is bigger than 1, the graph gets narrower. If a is smaller than 1, the graph gets wider. Wider would be like this. Narrow would be like this. On my exams, doesn't have to be perfect. Some people always ask, how much narrower is it? How much wider is it? I don't care. Okay? Let me know that it gets narrower. Make it narrow. And then the last thing that could happen is if a is negative, if a is less than 0, it reflects over the x-axis, meaning it's just going upside down. That out of the way. Also, if a is positive, it opens up. If a is negative, it opens down. Just want to run through a few examples. We'll talk about what the graphs actually look like. The examples are just going to say, graph the following. State there. Vertex. Axis of symmetry. Domain. The first problem said f of x is equal to x squared plus 3. Now the parent graph was x squared. We have a plus 3 on the outside. So look at what we talked about before. Plus 3 happens after the squared, and it says plus 3. What's that going to do to the graph? Moves it up 3. That's what the rule is, right? So the normal parent graph looks like this. That's what it is normally. We're just going to draw the graph up 3. Only all there is to it. Sometimes you move it left, sometimes you move it right. It looks like the vertex. It was 0, 0. Now it looks like it's 0, 3. The axis of symmetry is always just going to be x equals this number. Domain for all of these graphs is all real numbers because there's no radical and there's no denominator. And the range just tells you what could y be. Looks like the lowest value y could be for the graph is what? 3. So starting at 3, it just goes up for forever. That would be a perfect answer for this. What if we had a graph where it says f of x is equal to x plus 2 squared minus 1? So there's a couple things going on here. The outside. So after the square, there's a minus 1. What does that do to the graph? Yeah, it's going to move it down 1. But we also have a number inside the parentheses, which moves it which way? Well, let's look at our notes. It says plus 2. If the inside is a positive, it looks like it's going to go to the left. What this graph looks like. And again, it doesn't have to be exact. Just this is the normal graph. Draw a graph that goes left 2 and down 1. Have to be perfect. That would be a perfect graph. Text looks like it went to the left 2 and down 1. The axis of symmetry is going to be x equals the x value. What else do we have to find here? The domain is all real numbers. What's the lowest x goes here, or the lowest y goes here? -1. Here's a question in the final exam. Exactly the same as this. Everyone should be able to get this right. The only way I can make it harder, the absolute hardest one of these problems, would look something like this. If I said y is equal to -2 x squared plus 6x minus 1. That's in standard form. Remember what we talked about in the notes. We have to get this into vertex form. The way that we do this is we complete the square. We talked about this at our last class. We said when we complete the square, there's 4 steps. The first step to complete the square is that we isolate the variables, meaning we get the x's by themselves. That's what we talked about before. Second step, we factor as the leading coefficient factor out the leading coefficient from the x's. This means the leading coefficient's -2. So I'm going to divide the x's by -2. And we get y is equal to -2 times x squared minus 3x minus 1. Third step, we take half of the middle and then square it. We're going to take -3 divided by 2. Square it would be 9/4. And then our last step is we multiply number front and subtract. So what this is going to turn into is the new number was 9/4. Multiply that by -2, which is -9/2. And then we're going to subtract it. By doing this process, we created a perfect square. -2 times x minus 3/2 squared, and -1 plus 9/2 is 11/2. We had to get it into vertex form ourselves by following those 4 computing the square steps. 11/2 to do the graph. We're going to go up 11/2. 11/2 is about 5.5. -3/2 to the graph. To the right. What did we say a negative did if it was in front? Open down. It'll look like this. And then the 2 is bigger than 1. Look at your notes. What do we say happens if the number in front is bigger than 1? Bigger than 1, it gets narrow. So this graph, if we just combine everything we just said, separate the negative and the 2. The negative makes it open down. The 2 makes it be wider, narrower. So this graph is going to go to the right, 1.5. Flip over, get narrow, and then go up 5.5. That graph has everything that we talked about. So the vertex went to the right 3/2 and up 11/2. The axis of symmetry is x is equal to 3/2. Domain. We show real numbers. And the range. What's the lowest the graph goes? Goes up to a height of 11/2.